It's you. You are living on Earth. Earth floating in space with many other planets. They orbit a large, bright, burning star. So why do planets rotate? First, we need to know about Newton's 3 laws of motion. One of them is the formula force equals mass times acceleration. So what is force? A force is an action that tends to give a body motion, alter its motion, or distort the body. I don't understand anything, but
Force is what causes an object to move or deform.
for example, if you act on a ball and make it move, that is force.
Come to the acceleration.
Acceleration is the derivative of velocity, is the quantity that represents the change in velocity. In short, if Messi knows the above formula and knows the mass of the soccer ball, calculates all the forces acting on the ball, he can calculate the acceleration and the point of fall of the ball, from which he can be 100% sure that the ball will go into the goal or into the audience's face. This is Newton again. While sitting under an apple tree, an apple fell on his head. Instead of eating the apple, Newton asked the question, why does the apple fall down and not fly up? And he discovered that all objects attract each other. Then he proposed the law of universal gravitation. With this formula, m is the mass of the two objects, meaning the heavier the object, the more attractive it is. R is the distance between two objects, meaning the farther away, the weaker the gravitational force. Means you should not love from a distance. G is the gravitational constant and is found using the above formula. Gravitational force is also the reason that planets orbit the sun. This is because these planets are always in motion. When they were still meteoroids, they were moving. When they became planets, they were still moving. And even when there's nothing at all, they're still moving. It is called Newton's first law. The sun is extremely massive, so its gravitational pull is incredibly strong. It pulls the planets to move very fast toward it, as if they're going to crash into the sun. However, since the sun is also moving around the Milky Way, the planets miss the crash. The sun keeps pulling them in, and the planets keep missing the crash again. As a result, the planets follow elliptical orbits around the sun. And while all the other planets are nicely aligned, Uranus is like this. Gravitational force on Earth is called gravity. Gravity keeps people on the ground instead of flying. The only thing that defies gravity might just be drugs. Gravity leads to the definition of weight, which is different from mass. Mass is the amount of matter in an object, such as the amount of matter in your body. Weight is the gravitational force exerted by the Earth on an object. This means that if you go to the moon and weigh 20 kilograms, you don't lose weight, you just get lighter. To lose weight, you need a calorie deficit, meaning the energy you take in must be less than the energy you burn. And energy doesn't just appear or disappear on its own. It transforms from one form to another, or transfers from one object to another. This is the law of conservation of energy. Energy is a physical quantity that represents the ability to do work. To put it simply, energy exists in all objects and is used up whenever an object does something. For example, when a ball rolls on the ground, it has energy called kinetic energy. When your air conditioner is running at home, it uses energy called electrical energy. The unit of energy is the joule. There are many different types of energy, but fundamentally there are two main categories: energy conversion, such as kinetic energy and thermal energy, and reserve energy, typically potential energy. Any object possesses both of these types. For example, if you are standing at a height holding a phone, it is storing energy called gravitational potential energy. When you release the phone, this potential energy converts into kinetic energy, which is the energy of motion. As the phone falls and when it hits the ground, the potential energy is converted into kinetic energy.